welcome. This is just a voiceover of the operating system's background material. So the slide deck is obviously up on Brightspace, but this is just me doing a quick voiceover, okay? Just maybe partake some information that people may not glean from the slides. So just some background stuff. So one of the reasons why people ask why bother study operating systems at this stage, at this point in the world, everything nearly has an operating system. 20 years ago, there was a lot of gear out there that had very, very proprietary little kernels in there that did stuff, basic software, your washing machines, all that type of stuff. These days, things have moved on, and a lot of these devices have become, for example, embedded Linux, due to the fact that the cost of that has been driven down by all the Android phones. So everything is now driven by software. So your washing machine, which used to be a very simple little controller, and that controlled, how the knob was turned and what program it drove. Now, if you look at them, they have LCDs, they have flashing lights, they have loads of different stuff, and the odds are high. Nearly every one of those has a very simple operating system in there. All your routers that you have at home, they're all embedded Linux. All your set-top boxes used to be embedded Linux, now they're probably Android based. And so everything runs on an operating system. So we do need to understand operating systems a lot. The three main ones are listed there on the right with Windows, which the latest incarnation is 11, the Mac, and Linux itself. Okay. While we mentioned Android there a minute ago, one of the questions that get asked is Android actually an OS? And if we were in a room together, I'd ask you, what do you think? And I guarantee you half of you would say yes. Well, actually, Android isn't an OS. It's a framework, right? That in turn sits on top of an operating system. And then if you were to ask, what's the operating system? It sits on top of. A lot of you might guess or know that it's actually Linux, um, which then leads us to another question: uh, Is Linux itself an operating system? And definitely, most people in the room would say yes. But actually, believe it or not, Linux is not necessarily an operating system. You have the concept of a Linux distribution that sits on top of a Linux kernel. Okay, so the operating system is actually a kernel, which is all, and when you add in all the system libraries and the executables, you actually get a Linux distribution. So just for information, just so people understand it. Okay, so why is the operating system so important in all this that we're talking about in everyday life? Because if you get it wrong, it can be a bottleneck, right? So you're all used to, as say, your phones. At this stage, they're quad core, octo core. They're quite complicated beasts. They're doing a lot of stuff in parallel. Whether you're watching YouTube and the stuff, WhatsApp stuff going on in the background, like they're applications you use, but underneath that, there's an operating system that's also running those applications and running all the other stuff, like your virus checker that's going on in the background, your mail is syncing in the background. There's a lot of stuff to be done. And if you get it wrong, it can be a bottleneck, right? So operating system is really, really important. And we will touch on some of the topics over this module, that as to why it's so important. And say if you pick the wrong one, you can end up with portability issues. What does that mean? It means that you need to understand what operating system you use if you're writing an application. Is your application going to be written for only to run on Windows, only to run on Linux? Is it to run on Unix? If it runs on Unix, would it also run on Linux? If you want to run on all three, what should you write it in? Things like that, portability issues. Scalability issues, whatever operating system you decide to use. And, you know, these days they all scale single multi-core. This was more a question that was important 10 years ago. But nowadays, every single modern operating system will work nicely on multi-core because everything is threaded, multi-threaded, which we'll talk about in a few weeks as well. So every program can be broken down into processes and threads. And typically, if you want to get the best performance out of your system, they're running on separate cores that are in your device. And then the whole issue of concurrency issues, like you take for granted that you run stuff and it looks like say you're watching a YouTube video, it looks like that video YouTube is consuming all the CPU and running all the CPU because that's what you're seeing on the screen. But in the background, there's a ton of stuff also running. All the operating system threads and processes are running other applications. As I said, your mail might be syncing in the background. Loads of different stuff will be syncing in the background, WhatsApp, everything. So concurrency means lots of stuff working in parallel. And again, if you get that wrong, your stuff won't appear nice and seamless to be running perfectly at the right speed. Okay, so that's really important. We'll talk about concurrency a fair bit. And cost is also really important. Again, some of you will go on to have a career in IT management, and you may be person in a company who's asked to decide, well, should we stick with our servers, their window at the moment, should we flick to Linux, or vice versa, their Linux at the moment, should we move to Windows servers? And one of the things that always comes up is, oh, well, we should definitely move to Linux because it's free. And the question that I ask is, do you really understand? Is it free? And using Linux is free, building it is free, running stuff on it is free. But one thing that's not free is when there's a problem. And you've probably all heard of Red Hat. Red Hat made their money and continue to make their money because they charge for support of their Red Hat distribution. Okay, the Red Hat distribution is based on a Linux variant called Fedora, and you can use Fedora for free. But if you want to use Red Hat, you have to pay them support. All right, that's where they make their money. And so you have to factor it into what's called the total cost of ownership of your devices or your servers, because it's, I guarantee you, it's all very well to say, right, we're going to go Linux servers for everything, and you load up your web servers, your mail servers, blah, 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 whatever, and everything is running seamlessly, it's fine, and then there's a problem, and you have nobody in the company who can debug it or figure out how to fix it. Then you need support, all right? So you have to factor that in. So the cost is also a factor you need to allow for, and nothing is ever free. So the role of an OS, though, itself, has changed, right? So traditionally, years and years ago, whatever, not that long ago, before VMs, apps run on servers, and if you wanted to, say you had a business and it was web server based or whatever, and hosting a shop or whatever, so your app would run on a server. If you wanted to increase it or scale it, it meant you had to upgrade the server. You might have to buy a more expensive server, more expensive CPU, more memory, and that has changed over the years. That is no longer the model. So VMs came along, which were nice. I think everybody knows what a VM is at the moment. You probably used some of those ones on the right, either VMware or Oracle VirtualBox, and they allow you essentially to have a whopper of a server with a load of memory, and you can then have multiple VMs on it, which are essentially multiple operating systems running in parallel. And you might run certain applications on certain VMs, and you might run a mail server on one VM and multiple web servers on another VM, and you can run Linux on top of Windows and Windows on top of Linux, and that's actually very powerful. And we'll talk more about virtualization later on in the course. But something happened after this that has changed it again. And again, if I was in a room with you, I'd ask you, do you know what it is? And some of you might come up with it, but it's containers, okay? And containers basically have come along again. We have a server with a huge amount of memory and powerful CPUs. And what this allowed you to do is to run your application, instead of on its own VM, on a container. And the main difference this makes is obviously a container is more lightweight than a VM. It takes up less memory, takes up less CPU power, so you can get more bang for your buck with your server if you run containers versus VMs. And there are advantages and disadvantages of each, which we will come back to in a few weeks. Okay. So the official role, if you were to look at it, of an OS, and this is all background information, it's defined as a set of programs to coordinate all the activities among the computer hardware. Right. So if you look at the picture on the right, it's like a little cake, right, with layers in there. So the whole point is that up at the top here, you'd have your applications. Down the bottom, you might have your hardware. And this is the operating system sitting in the middle. And this is a very important word called abstracts the users from the hardware. So the users are using the application on the top layer of the cake, and the hardware is down the bottom layer. And the OS is responsible, let's say, for abstracting it, which means hides all the fancy instructions, the fancy code that needs to run that hardware, and prevents nice APIs to applications so that they can easily manipulate the hardware. Or you can change the hardware. You can plug something out, plug in a different LCD or a different card, whatever. Okay, so it's a layer of software between you and the hardware. Another way of looking at it, there's another picture, and that's the final one. So you've got user on the left here, we've got user up top, then application, then operating system, then hardware. So there's like 4 layers involved. And these are the typical tasks of an operating system, all those different things. If you read around those, you'll recognize most of those. All right. So what are these OS services that typically sit all the way around Here, okay. Well, we have to have the ability to execute programs, right? Whether they're applications or whether they're OS programs. You have to be able to develop stuff. So you've all used IDEs or editors, debuggers for Python or whatever. You need to be able to do that. I/O operations, everything from the keyboard to the screens, to USB sticks, to the hard disk, to SSDs, everything. They're all I/O operations. And the OS has to have a load of what are called drivers to be able to talk to those hardware devices and do the I/O. So the OS has to provide all those services. Also, file systems. Everything you do, you're usually storing files on your SSD or your hard disk or on your DRAM. So you have to be able to get at those files, open those files, create them, write them, read them, move around them. That's called file system manipulation. And the beauty of an OS is it typically will offer you more than one file system, right? There are certain file systems that are designed to work on phones versus desktops, and whether they're on the type of memory it's sitting on, whether it's SSDs versus hard disk versus a thing called NAND devices, okay? So there's all different file systems. Communications, these processes, and we'll talk about processes next time as well. In the next deck, processes are the heartbeat of, processes and threads are the heartbeat of everything that runs on an OS, right? So they're like mini little programs running. So obviously they need to talk to each other every now and then. So those processes need to talk to each other. And there are inter-process communication methods that we'll talk about in weeks to come. Error detection, not everything always works. Things go wrong. You need to have an ability to be able to find out what went wrong, whether that's a log message, an event log, or a message on the screen, a big dialog box coming on the screen telling you this issues. OS has to be able to do that. And resource allocation, allocating resources to users or processes running at the same time. One of the biggest ones there is DRAM. I think everybody realizes that DRAM is the most important memory in the device. The more DRAM you have, the quicker it will run. So allocating those resources fairly amongst the OS versus the users versus the applications is really, really important. The counting is basically just logging stuff, all right? Usage statistics, or God forbid, if someone has to pay, CPU usage, things like that. And then finally, protection and security, which has become more and more important over the last 5 to 10 years. Making sure that if someone hacks in, that they can't get at stuff, maybe that they're not supposed to get at stuff, making sure you can't jump from one account to another. If you do get in, making sure that if you do get in, you can't access what's called root on a system, which will allow you to do anything you want. Okay, so there's lots of security concerns there as well. We mentioned system calls. This is the layer of software that an OS provides up to the applications to allow the application to do all those services, right? So again, if we were in a room, I would ask you, why do you reckon that all these system calls are written in mainly C, but some of them are written in C++, not Java or Python? The question is why? And the answer is that Java and Python are a much higher level language. They're much slower. They don't allow you to easily access hardware, whereas C is optimized to interface with hardware and it runs a lot quicker. A C executable will run a lot quicker than a Java executable. The reason being, a Java application sits on top of what's called a JVM, which is Java Virtual Machine, and the Java Virtual Machine sits on top of the OS. Now, what's nice about Java is you can write an application and it'll run on a JVM that runs on Windows or Linux or Unix, right? So in other words, highly portable, but you don't write operating systems in Python or Java. Okay, so you access all these system calls via an API. Some famous APIs, the Windows one, POSIX is the one used for all Unix, Linux. And in case you didn't know, Mac OS is essentially a version of Unix. Okay, it's called BSD Unix, if you look it up. Other famous API, Java, and obviously the other massively famous one is Android, okay? And this leaves us finally this sort of abstract theoretical idea, and we will come back to this. So what does it say? It says a programmer views a computer as a mechanism that can access, transform, and store information. So information is key, that's data, and you have to be able to then work on that data. So we have two fundamental units: a unit of computation, which is a process, all right, which is a set of instructions doing something, and a unit of information, which is a file or a stream of data that the process will in turn work on. Okay, and that's basically the intro stuff for the operating system. So I'll shut up now and I'll